Good morning, everyone. So today we will be seeing the examples on Mealy and Moore machine models. So this is the question. Explain the prevalent condition in the segments of the state diagram shown and identify whether it is a Mealy machine or a Moore machine. Okay, they have given two diagrams. This is one problem. Okay, this is one problem and this is the other problem. So first let us see this problem. So what they are telling, seeing this diagram, you have to tell whether it is a Mealy machine or it is a Moore machine. Okay. So now here it is P, that is state P. So this is state P and this is state Q. One second, I'll edit it. So the diagram is not correct actually. Like it is not being visible. So you all take down the diagram. This is state P and this is state Q. Here it is X bar. Here it is X. I'll write down X bar, okay, and Z bar because I cannot indicate. So I'll be writing X bar, Z bar. Here it is X, Z bar. Okay. So this is the question. So this is X bar, this is Z bar, and here it is X, Z bar. What they have told, there is two states, that is P and Q, and here it is X and here it is Z bar. Here it is X bar, Z bar. From the state P, it is moving towards Q. Okay, when input is 0, X means it is input, output is Z. Okay, so it is moving from state P to state Q when input is 0 and output what you will be getting? You will be getting 0. Bar indicates 0. If it is without bar, it indicates 1. Okay. So P remains in the same state when the input is 1 and output what you will be getting? You will be getting it as 0. Okay. From the diagram itself, you can tell whether it is a Mealy machine or it is a Moore machine. How? In the sense, when you see the diagram, okay, this P doesn't have, see, you compare this diagram and this diagram. Here you will be getting the output here itself, within the state itself. So it means it depends only on the output, it does not depend upon the input. Okay, here it depends both on the input as well as on the output. So it is called a Mealy machine. This, if it is within the diagram, okay, it is a Moore machine. If the input is outside the diagram, it is a, this is a Moore machine and this is a Mealy machine. If within the diagram you are getting the output, it is a Moore machine. If you are getting the output outside the state diagram, that is and when input is 1, okay, it remains in the same state and the output is 0. Okay, so when input is 0, that is X bar means it is 0. When input is 0, it moves to the next state, that is Q, and the output you will be getting as 0. So now you will be writing Q plus is equal to, that is next state, it is a function of input as well as output. Okay, the next state, it is a function of input as well as output. Hence, it is a Mealy machine. See here, it has been given here. there are two states P and Q. Okay. When at state P, when input is 1, okay, when input is 1, X indicates it is 1. Okay, when input is 1, it remains in the same state, and what is the output? It is Z bar. Z bar indicates it is 0. Okay. Next, when input is 0, X bar indicates it is 0. When input is 0, it moves to the next state, that is Q, and the output, what it is? It is Z bar. Z bar means again it is 0. So, if suppose I take P as the present state and the next state as Q, okay. So always Q plus plus indicates it is next state. So next state is a function of input as well as the output, as well the output, that is Y. Y indicates it is output. It is function of input as well as the previous state, that is Q. Okay. So what does it means? It means it is a Mealy machine. Okay. So in the same way, here it is one more problem is being given. So how many states you will be having? You are having 3 states, A, B and C. Okay. There are 3 states, A, B and C. So now let us consider when it is at state A. So when it is at state A and when input is 1, okay, it makes a transition to state B, and the output what you are getting, it is 1. Okay. So in the same way, when input is 0, it makes a transition to state C, and what is the output? It is 1. Okay. Here you can see the output depends. That is, this is output. Okay. Within the circle, this is output. So output depends only upon the present state. It does not depends upon the next state. Okay. So the output depends only on the present state, and it is represented within the state circle, that is within the circle. So that means it is a Moore machine. Okay. It is a Moore machine. Now let us see one more examples. Identify the transition patterns and types of machines in the following cases. So first let us take S1, S2, S3 and S4, and there are two inputs, that is P and Q. Seeing the diagram itself, you can tell which machine it is. It is Mealy machine. Why? We are not having output within the state circle, so it is a Mealy machine. So there are two inputs P, Q. Okay, there are two inputs P, Q, and what is the output? It is Z. And how many states we are having? We are having 4 states. What are those? That is S1, S2, S3 and S4. So we are having 4 states, we are having 2 inputs and we are having 1 output. So let us assume that it is at state 1, S1. Okay. So when input is 0, 0, that is PQ is 0, 0, it remains in the same state. And what is the output? It is 0. Okay. So when input is 0 and 1, that is P bar means it is 0, Q means it is 1. So when input is 0, 1, okay. So it moves to which state? It moves to S2, and what is the output? It is 0. Okay. In the same way, when input is 1, 0, this is P means 1, Q bar means 0. When input is 1, 0, it moves to which state? It moves to S3, and what is the output? It is 1. Okay. In the same way, when input is 1 and 1, 1, that is when P is equal to 1 and Q is equal to 1, it moves to state S4 and the output is 1. Okay. So seeing this diagram itself, you can tell it is a Mealy machine. Why? Because within the circle, you don't have the output. The output is represented outside. And the next state Q plus, it is a function of input as well as the output. And the output, it is a function of input, that is P and Q, as well as it is a function of the previous state. And hence it is a Mealy machine. It is been given here, you can go through that. So now let us see for next example. So there are how many states? There are 3 states, S1, S2 and S3. There are 3 states. Seeing the diagram itself, we can tell which machine it is. It is Moore machine. Okay, it is Moore machine. Why? Because the output is indicated within the state circle itself. Okay, this is called as the state circle. Within the circle itself, the output is being mentioned. So S1 is one state, S2 is one state, and S3 is one state. When S1, and how many inputs we are having? We are having 2 inputs. That is A and B are the 2 inputs. And output is what? It is Q. Okay. So when uh, A bar B means, when A bar B means it is 0 and 1. When the input is 0, 1, it remains in the same state and output is 1. Okay, Q means it is 1. Okay, as well, when input is 1 and 0, 1, 0, it remains in the same state and the output is again is equal to 1. Okay, in the same way, when input is 0 and 0, 0, 0, because we are having 2 inputs, A bar, A and B. So here it is A bar, here it is B bar. Bar indicates it is 0, 0. When it is 0, 0, it moves to the next state, that is S2, and the output is what? It is 1. Okay. In the same way, when input is 1, 1, it moves to S3 and the output is 0. Okay. Seeing the diagram itself, what we have told, it is Moore machine. Okay. Next state is function of only the inputs. It is not the function of output. Okay. That is Q plus, it is function of only inputs. Next, coming to the analysis of sequential circuits. So next topic is analysis of sequential circuits. So there are few steps. You can write down these steps. Okay. So these steps are very important. If you know the steps, you'll be able to do it. And the problems on this will be for 10 marks or 12 marks. It is very important. So what is the procedure? First, you have to identify the state variables. So what are the variables? That is flip-flop outputs. Then, seeing the flip-flop outputs of flip-flops, you need to identify which flip-flop it is. That is D, T, D, T, J, K. So all these things you have to identify. Later, what you have to do? You have to write the flip-flop equations. Then next, what you have to do? Construct the K-map. Then we need to fill the excitation table. So these are the flip-flops function tables. Okay. So then next, what is the next step? Write the state diagram from the excitation table. So let us see first how it is. So now analyze the following synchronous sequential circuit. Always synchronous means, as I've already told, it is given to the same clock pulse at the same time. Okay. For one clock pulse. So now what they have told, first step is what? Identify the flip-flop outputs. So what is the flip-flop outputs? It is A, B, C. So A, C, where it is B and here it is C. That is flip-flop outputs. So identify the state variables, that is nothing but the flip-flop outputs, that is A, B, C. This is your first step. So next step, what they have told, you have to identify the flip-flop. So which flip-flop it is? It is JK flip-flops. Okay, JK flip-flop. Now, what is the next step you have to do? Write the flip-flop equations. So what is JA and KA? See here, JA and KA, it is equal to JA and K. It is connected to where? It is connected to state B. Okay. So what it is nothing but J is equal to K is equal to B. So I'll write down B. Okay. So next, what is JB and KB? KB is different. So JB is equal to what? JB is equal to C. And what is KB is equal to 1 and KC is equal to 1. Okay. So what is JC? JC is equal to nothing but B bar. Okay, it is B. If this is B, what will be this one? This is B bar. So JC is equal to, it is connected to Q of second flip-flop, that is nothing but B bar. Now we will write the, if you want you can write the K maps like this. Construct the K map. Or directly I will write the table. So what I will do, I'll write the present state A, B, C here. Okay. Next state will be A plus, B plus, C plus. Next, flip-flop inputs. That is JA, KA, JB, KB and JC, KC. So what they have given? What we were having the equations? JA is equal to KA is equal to B. Okay. So what I will do? I have written like this. So what actually our main intention is to identify the this one sequence, what sequence we'll be getting. So previously what we were doing, sequence we were having, we were putting the sequential circuit. So now what they are doing, they have given us we are going opposite previous problems what we have done. In the same way, this is opposite way. So first we are having the circuit, sequential circuit. From there we'll be getting the sequence. Previously what we were having the sequence, we were drawing the sequential circuit. Okay. So now I'll write down A, B, C, present state. I'll write down the next state A plus, B plus, C plus. I'll write down all this, all the sequence, that is 0, 0, 0, 0, 0, 1. If you are having 3 inputs, 3 variables, so how many combinations you'll be having? That is, you'll be having 8 combinations from 0 till 7. So this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. I don't know this one. This part I don't know. I have written according to ABC, I'll be having JAKA, JBKB and JCKC. So what is my question? Like what they have given, what we have got the equation, that is JA is equal to KA is equal to B. Okay. So what is B here? It is 0, 0, 1, 1, 0, 0, 1, 1. So I'll write down 0, 0, 1, 1, 0, 0, 1, 1. In the same way, what is KA? It is also B. So it is 0, 0, 1, 1, 0, 0, 1, 1. Like this I have filled up JA, KA. So what is JB? What they have told JB? What we have got the equation for JB? It is nothing but C. Okay. So I'll write down what is JB. It is C. So C is what? 0, 1, 0, 1, 0, 1, 0, 1. So I'll write down 0, 1, 0, 1, 0, 1, 0, 1. So JB is equal to C. I have wrote whatever C is having. Okay. So what is KB and KC? It is equal to 1. So all I'll fill it with 1, 1, 1, 1 like this. 1, 1, 1, 1 like this. So what is JC? It is nothing but B bar. So what is B bar? It is 0, 0 means it will be 1, 1. If here it is 1, 1 means here it will be 0, 0. If it is 0, 0 means here it will be 1, 1. In the same way. So now I have got this. Okay. This I filled up. JK, JB, KB and JC, KC. Now next what I have to do? I have to write this one. A plus, B plus, C plus. Okay. So now for this, we all know that if JK is 0, 0, see this. If it is 0, 0, it will follow the same state, that is previous state. So if it is 0, 0, that is for A plus you have to see. If this is 0, 0, it will be Q. Q means that is A. If A is 0, it will be 0. Okay. In the same way, if it is 0, 0, whatever is A, that will be here 0. If it is 1, 1, it will be Q bar. Okay. If it is 1, 1, it is Q bar. Q bar means if this is 0, it will be 1. Okay. So if it is 0, it will be 1. You have to see this one and you have to fill this one. Okay. So next again it is 0 0 means again it will follow the previous state. Previous, if it is 1, it will be 1. Okay. So again here it is 0 0. Previous state is 1. So this one will be 1. Again when it is 1 1, it will toggle. If it is 1, it will be 0. If it is 1, this is 0. Okay, 1, it is 0. In the same way, you have to fill up for B plus also, seeing what? Seeing JB KB. So if it is 0 1, so 0 1 means it is 0 only. So 0 1 0. If it is 1 1, it will toggle 1 1. If B is 0, it will be 1. Okay. So if it is 0 1, again it will be 0. If it is 1 1, it will toggle. Toggle means this is B plus, means you have to see for B. If this is 1, then this will be 0. Okay, again if it is 0 1, that means it is 0. Wherever 0 1 is there, you put it of 0. And wherever 1 1 is there, what you have to see? You have to see the previous state. If it is 0, then it will be 1, like that. In the same way, you have to fill up for C plus also, seeing what? JC, KC. If it is 1 1, again you have to toggle. For that toggling for C plus, you have to see C. Okay. If it is 0, it will be 1. Okay. If it is 1, it will be 0, like this. This is 0 1 means again it will be 0. 0 1 means JCKC, if it is 0 1, then C will be 0. So if it is 0 1, it will be 0. Okay, if it is 0 1, again it is 0. So 1 1 means it will toggle. So for toggling, you have to see the previous state. If it is 0, it will be 1. If it is 1, it will be 0. So now what sequence we have got? You have to write the sequence, that is state diagram. So when the present state is 0, it is 1. When it is 1, it is 2. Okay. When it is 2, it is 4. Okay. After 3 also it is 4. When it is 4, it is 5. When it is 5, it is 6. After 6, it is 0. After 7 also it is 0. If you want, I'll write here. Zero, 1. After 1, again it is 2. After 2, it is going to 4. Okay. From 3 also again it is 4. When it is 4, it is 5. When it is 5, it is 6. Okay. When it is 6, back to 0. I'll write here above 0, again it is 7. Okay. See here. When the previous state is 0, the next state will be 1. When the previous state is 1, again it is 2. Okay. When the previous state is 2, it is 4. From 3 also it is 4 only. When the previous state is 4, it is 5. So when the previous state is 0, it is 1. After 1, again it is 2. After 2, again it is 4. Okay. Here again it is 3. Okay. From 3, again it is 4. At 4, after 4 it is 5. After 5 it is 6. After 6 again it is 0. Again from 7, again it is 0. Like this it is. So now what you have to do? You have to draw the state diagram. See here. So after 0 it is 1, that is after 0 it is 1, after 1 it is 2, after 2 it is 4, after 4 it is 5. First we will write down the circle, what correct sequence we are getting. After 4 it is 5, after 5 it is 6, After 6 again back to 0. So next what we are having? 3 and 7 we are having. Here it is 3 which will count again back to 4. Here it is 7 again it will come back to 0 like this. So this is called a state diagram. So I'll give you one assignment question. Analyze the following synchronous circuit. Okay. You all do this. If you are unable to do, we will do in the next class. Any doubts? Any doubts?